Hi, I'm Will Sargent. I'm a software engineer at eero. I work with observability and distributed systems and logging. I'm here to talk to you about conditional distributed tracing. I think it's an interesting topic and I hope you like it. So the interesting thing about conditional distributed tracing is why do it? Why is it there? And to begin with that, we have to ask questions about what distributed tracing is for and what kind of experience it gives to people. And when you talk to people about, well, what is tracing, what problems does tracing solve? It's usually roughly the same list. It starts talking about health of the overall system, being able to have visibility and observability across the system. And interestingly enough, the concept of time and breakdown of time comes up a lot. So you get into latency trends, how long a particular thing takes. You get into long tail and outliers. You get into a control flow graph because you can actually have hierarchy in tracing. And that gives you an indication of what's being called and also more subtly what isn't being called. And by its nature, because tracing can actually happen concurrently, you end up with a nice asynchronous process visualization as well, which is something that you typically don't get with straight graphs. You can have multiple things happening and you can have things stop and then start again and be able to see this in kind of a view. But one thing actually shows up again and again in distributed tracing, which is it's used as a tool for debugging microservices. And I've always found this to be an interesting phrasing because debugging services doesn't always mean what you think it does. So conditional tracing is flexibility to change the way that tracing works. And in particular, it's the way to change the way that tracing works based on behavior code written by the application. That is, it's not being done by an open telemetry collector or any kind of exporter outside of the system. It's the application itself deciding when and where it should be actually producing a trace and when and where it should be sampling one. And in some ways, this is an exploration of just what you can do with open telemetry, because I think there's an emphasis on what vendors provide rather than what applications can provide into systems. But also conditional tracing is there because debugging is a different concept to different people, and it means different things to different people. And this actually comes up almost immediately when you start looking at the people who complain about tracing. Matt Klein in particular, this is actually from 2018, which kind of dates it, says, you know, looking at a pretty trace page is fun, but how often does a user find a trace which is relevant to the debugging needs? And he uses the phrase debugging needs and goes on to say they don't get a lot of real use, primarily because developers are used to logging and stats, and it's too hard to find relevant traces. And this is something I find really interesting because this is somebody very clearly coming at it from a certain perspective. Is like, yeah, this looks cool, but have you tried using it? And he specifically relates it to the UI, which I think is, I mean, it's a good start, but I think there's more to the problem than this. And Sydney and Sridharan follows us up in a very widely known blog post called "We've Been Doing It Wrong," which also talks about debugging. And debugging to her is being able to quickly and cheaply test hypotheses and refine one's mental model. And looking at a trace is inherently static. And looking at a portion of a trace where something interesting and unusual is happening is not something that is necessarily conducive to debugging. It's not necessarily what a trace provides you, and it's not conducive to debugging in the sense of the word that they're using it. And Abby Bangser follows up on this and says, a key to observability is being able to get both a high-level view and the detailed debugging. And if you use two different tools for this, each is not independently an observability tool. So if you're using a high-level tool and you're seeing a trace, but that trace doesn't actually let you drill down to a lower level and be able to get detailed debugging, if you have to go over to another tool to get it, then you're not looking at something that lets you observe, because you're not looking at a tool that lets you zoom in. And you're not looking at a tool that lets you explore. And I thought about, like, I knew about these before, but it wasn't until I actually read this paper, Debugging Incidents in Google's Distributed Systems, that it really kind of clicked for me that software developers, software engineers, SWE, have a different mental model than software site reliability engineers. And the model is an indication of how they actually view debugging, what kinds of things that they view as bugs, and how they interact with that. And what it comes down to is, for what distributed tracing does, it's very good at debugging incidents that site reliability engineers focus on. So incidents in production, distributed tracing is very good at allowing you to see, like, where's the long tail, where's the system that I have to focus on. But for a software engineer, debugging is a different thing entirely. And it's an error in logic, it can be an error in internal state. And the way that they actually resolve debug incidents reflects their mental model, in that they check logs, they try to see an error that can indicate a failure occurs, whereas the SREs are used to looking at the entire system and aren't really focused on a particular log or trying to find the exact underlying cause. So with that in mind, knowing that software engineers, when they're talking about debugging, are talking about something very different, we can see that the way that software engineers try to debug using distributed tracing is also different. Namely, when in doubt, software engineers, developers add more spans. They start off with something that is not quite fine-grained enough for them and adds more detail. And then they add a span to the trace. And then they look again, they do another compilation, they do another deploy. They see that they need more spans for that. And then they keep going. And developers are very well aware that really, when it comes to debugging, we only have one tool. We have printf debugging, and we've dressed it up in various formats, and we've called it logger.trace, and we've called it logger.debug, etc. But that's really the ability to turn off a printf statement in some form or another. And developers are well informed about printf and know that it works in situations, especially microservices, where you don't have access to a debugger, where you can't actually stop an application or, like, inspect its threads. But they're also aware of its shortcomings, saying that you are halfway towards either telemetry or towards tracing. And I swear to God, again, this is just a dead-on statement here, in that, spans are the new printfs. And when it comes to what developers use printfs for, well, they tend to use it for a lot. And if you turn on detailed debugging in production, then it will almost immediately overwhelm your system. So debugging statements are typically like a state dump. You've got execution tracing, which spans actually helpfully give you for free. And you've got, like, event reporting, which is closer to the honeycomb sense of events, that there's been a state transition or a request is terminated, etc. But developers have very specific debugging needs. They create a pool of data, they throw in a bunch of spans or printf statements or what have you. They dump internal state and look for state transition and indicate, like, when there's particular branches in logic. And so they create a pool of data. Then they start fishing around that pool with hooks and queries and what have you until they have a fairly good idea about what piece of code is responsible for it. And then usually they keep the most useful statements around as diagnostic logging for later. And this works with logs because you can actually keep debug logging in production as long as you have a priority system. You can say, is logging debug, and it will return false and just have no operational effect. But spans, because they're printfs and there is no priority system in there, if you add more spans down to the method level, say, then you will get more data. And it gets far too detailed in order to be able to see anything in there because you don't want to see everything at once. You only want to enable debugging, spans, tracing, etc., for a particular branch. But if you do it globally, then you get more data, you get more sampling, and the overall usage of the system goes down because you're trying to reconcile the sheer volume of the data with what comes out. And this is something that, again, various organizations know about. And the bones of the system, it's a very good paper by Microsoft going over the Windows 10 telemetry system and the case study there. They mentioned that what's really important for them is to be able to get log stuff at a pretty granular level and turn it on and off at real time, and then be able to get the performance back when it's turned off. So they want to be able to turn off for a particular branch, for a particular subsystem, debug logging, showing them exactly what's going on, be able to take the hidden performance, and then turn that off again afterwards. And we don't really have a way to do that in distributed tracing, but I'm going to show you a proof of concept, and we're going to walk through that. So the goals for this conditional tracing that I've got here is we want to allow behavior to depend on application-specific date. We want to be able to add more information to spans. I mean, like we can't really add information to traces, but we can add extra information and we can give the application and the developers the ability to change that on the fly without having to restart the system. We can give them the wheel. And if you go to GitHub, GitHub has it available as Sargent conditional tracing. And the tracing is an open telemetry SDK hook that is driven by Groovy statements. So there's two systems that I've implemented. One is conditional sampler, which allows you to say, yes, I want to sample the span, or no, I don't want to sample the span. And then there's a conditional span builder, which allows a script to determine whether you're going to create a new span or just return span.current. And these aren't particularly fast, and I have not spent a lot of time trying to make it very secure. You can add an HMAC, but typically what I think is going to be the best option here is to allow this to be a targeted feature flag. That is, you can always add code that says, when you turn this feature on, when you turn this flag on, then we actually also evaluate a Groovy script in response to this, so that you have the ability to turn this feature on and off dynamically, just as you do others. And I'll demonstrate how that works in a second. So what we start off with here is a conditional tracing demo, which starts off with level 1, 2, 3, 4. And in a minute, I am going to start up IntelliJ, and I'm just going to show you how that looks running. So I'm going to do the demo thing now, and I hope that the demo gods smile on me. Let's present the window of IntelliJ. And IntelliJ, you can see here that, let's start running it. There we go. So this is just a simple Gradle script. And if you look at the main project, you can see that I've got some fair amount of open telemetry, and I'm doing manual instrumentation here because I'm passing in these two Groovy scripts into the open telemetry. I also have launch darkly implemented here with some context keys, and I am setting this up with the actual context. So launch darkly keys and values are being passed into the context and being used here so that the spans are actually aware of them. And then it just goes through level 1, level 2, level 3, and level 4. And each of these comes with a wrap, which is using a span builder here. It calls make current. We add enter and exit here, and then we accept the span in between there. So you can see, like, when we're calling this in wrap, then there's automatically a span wrapped around this with enter and exit methods provided. So that's the base level functionality. And if you can see here, what we've got is, so let's return this as always. You can see right now it's actually ignoring debug spans 2 and 4. And that's because we actually had the debug attributes turned on. So if we scroll down here, you can see it's doing 1, 2, 3, 4, 1, 2, 3, 4. And if we change out this feature here and say debug by feature flag, then we can see it show 1, 2, 3, 4, 1, 2, 3, 4, again, because it's actually running through. But looking at the feature flag here, we can say we've got an LD system here, and we've got a user system here. And we can say that if this is not this particular user that we are expecting, if the user has this test flag set false, then we can simply ignore it. So let's actually try to start. Let's actually look at the conditional sampler now. And the conditional sampler is using the SDK. So let's go back here, pick the Chrome tab, conditional tracing. So the conditional sampling demo allows you to make 3 decisions. It allows you to drop, it allows you to record, or it'll allow you to record and sample. In practice, what you've got is essentially like yes or no options rather than 3 options, because what happens is the exporter tends to get confused if you drop a span and then you have a child span which is not dropped because it doesn't know what it attaches to. So you end up with code that will drop it by random nanos, so it'll drop 1 out of every 3. Then you end up with a system which ends up having a missing span in the middle. So that in practice means that, like, if you're going to drop a span, then you have to drop everything below it as well. So the conditional span builder demo here, when it's got the debug attribute, you can see here we can look at attributes in the span. And this is actually something that you typically can't do with spans otherwise. Typically, span is a write-only API where you can set stuff, but you can never get it back out. But because we're in the SDK, we actually can ignore that. So what we do here is we say, if it's got the debug flag on it, then we know we can ignore it. We return false. And if it returns false, then we just call span.current, and we return the already existing span on it. And right now, I don't actually attach the attributes to the existing span. So it slightly breaks the span builder semantics, but it's easy enough to change that if you want. And then what we end up with is we end up with span level 1, and we end up with do stuff 2 and do stuff level 3. And the punchline here is that there's also 4 defined here at the end here, which is very close by, so you can't really see it. But you can see that, like, you end up with a span system which allows you to roll up stuff which is debugging, which is fine-grained, so that when you are querying the system and when you are producing normal amounts of logs and normal amounts of spans, you only see the stuff which is high level. But if you want to drill down and get a more detailed picture, then you can change the Groovy script on the fly and start producing spans with that detail that you want, and then be able to turn it back down again. And yeah, so you can do that by the data. You can do that by using a launch darkly. You can also, of course, use internal state of the system. So here we've got an example where you can say by deadline, and you can say this time plus 10 minutes, etc. And if it's after that, you can turn it off. You can also specify conditions where if you are under a resource constraint, for example, there's high CPU, or there's low amounts of memory, or there's a lot of memory allocation pressure, then you can say, let's just not do spanning at this detail anymore. And of course, because it's all a Groovy script that is passed in, you can source that Groovy script from anywhere. Right now, I've got it coming from the file system, which is just easiest for me, but you can have that coming from Redis, you can have that coming from a central database, etc. So you can have that globally distributed or centrally distributed and have that pushed out to all of your applications at once. That, of course, can read Groovy and are happy to work with it. And yeah, so you can break out and fold spans at runtime. It elides spans. It does require some SDK mashing, unfortunately, because OpenTelemetry SDK is not really set up for this out of the box. And the bit I'm actually most sad about is that there doesn't seem to be a way to reconstruct an elided span afterwards. It's not recorded. You can't send that off into another channel. You're kind of stuck with whatever, 10,000-foot view that you have of that span, rather than being able to query a local system or investigate like a local cache and be able to fill that in later. So it does have some drawbacks, but I think that if nothing else, it's a useful way to open up a question, which is that developers and SREs conceptualize debugging differently. When they're solving problems, they're solving different kinds of debugging, the debugging logic flaws and trying to drill down versus debugging incidents and trying to resolve the issue. Reconciling the debug traces in production is something that traditionally in logging has involved conditional logic. And in order to add that in order to add that conditional logic into the SDK, we need to do a few interesting things. But this is, I think, something that can be expanded on. And I think it's something that can be used to think about using tracing in different ways and considering different audiences. And I think that's about it. So this is a good time for questions. Let me know what you think and how this works for you. Thank you.
That was super fun. Watching your talk here, it really sinks home to me that we are in the infancy of tracing and what tracing is going to do for our systems. What we think of as tracing today is so new to so many people, but we're just beginning to be able to do things like inspect within events and do cross span queries and all this stuff. What led you to start investing so much time into this, where you're working?
Distributed tracing is kind of an outgrowth of my interest in logging. Basically, if I wanted to look at a particular trace, then there were times that I wanted a lot of detail and I wanted to see absolutely every single feature. And then there are times when I wanted to just see what's the overall Came into database, went out through the HTTP client, etc. And I wanted to be able to switch that around at runtime, and I couldn't do that.
By the way, Hetty, out of my own personal interest in logging is one of the nerdiest things anyone's ever said. Like, you should get better hobbies. Logs are terrible.
I really don't. And again, I think it's a difference in perspective. I'm a software engineer. Like, if I can look at debugs and traces all day long, and even better, if I can actually extract useful information out of them without having to actually look at an individual log, but rather have a machine process.
I'm right there with you, and I think it's terrific. In
fact, I don't need better hobbies. I just need more people with my hobbies. That's basically where I'm coming from right now. Is like
I have higher standards for their hobbies.
I am a proselytizing zealot at this point. So
you
I make
absolutely
no
are. And I'm so glad that you are, because I think that we proselytize a lot of the same things in just different ways. I was also thinking about what you said about, SREs and software engineers thinking about, and the language that you used is very different. I know we only have a minute left. I feel like we could feel like an hour just like ranting about this, which we should do sometime. You haven't been on Olliecast yet, have you?
What?
Olliecast, our podcast?
No, I have not.
Yeah, we should just do a whole episode about this stuff, because when you're talking about SREs and incidents and everything, I'm just like, oh, I guess we do. I don't think of it as that way. I think of it so much more in terms of like software engineers are looking at code, and and SREs are looking at systems. Where in the system is the code that needs to be debugged, as opposed to like, what is the logic that needs to be debugged. And I often find that like the hardest part of resolving an incident, as you say, is figuring out where it is. And once you know where it is, like everything else is easy. But like that's like 90% of the battle right there.
Yep, absolutely. And it gets even worse when like it doesn't seem to cause a failure in the system, and instead it corrupts data, because at that point,
it's my favorite.
if it's not request response oriented, and you actually end up with internal state, and that ends up building up. Yes. The longer the delay in input to result, the more likely you're about to have things explode. And I think that's where things actually start going off the rails, is the dichotomy there.
Absolutely true. And, for all the people who are cringing out there in horror and going, I've never lost data, I have news for you. You have, and you just don't know it. So on that cheery note, thanks, Will.
Thanks.